Hello, and welcome to our next installment of Enriched Geometry Distance Learning Notes Taking Situation. Your note sheet that you should have out should look like this one. We're going to talk about inequalities in one triangle. We're totally switching it up from what we were just doing before. I think you will enjoy this lesson much more than the other two. There's way less vocab. It's a lot more just a little easier, okay? So, without further ado, if you have your sheet out, let's get started. Oh no. There we go. Here it is. So after today, you will be able to compare angle measure and side lengths of triangles. Okay. So let's just kind of talk basics real quick. What's an inequality? An inequality, right, is just like a mathematical expression, but instead of typically we're used to seeing equal signs, an inequality uses an equality symbol. So like we could have a less than, we could have greater than, we could have things that are less than or equal to, or greater than or equal to, right? So instead of having like an equation, you would have an inequality, and then you would just solve like normal. We're not going to do anything solving wise today. We're just going to be comparing, okay? That's all you're doing really. Is it bigger than? Is it less than? That's kind of the gist. So now this is where you are in your notes. You guys have this. It says, what do we know about angles 1, 2, and 3? So I'm kind of making you think back to beginning of November probably, when we talked about angle measures in a triangle. We learned like a shortcut is kind of what I called it, but a relationship between these three angles. So this would be an exterior angle, right, of our triangle. And then these would be our two remote interior angles. And if you remember, we said that the measure of angle 1 is what? It's equal to adding these two together, right? So that would be like an equation, correct? So the measure of angle 1 is equal to the measure of angle 2 plus the measure of angle 3. But now let's for fun say I got rid of the measure of angle 3. We just got rid of it. How does the measure of angle 1 compare to the measure of angle 2? Well, wouldn't it have to be bigger than the measure of angle 2 since it takes a whole nother angle added to 2 to even get to angle 1? Does that make sense? So if I just got rid of angle 3 over here, I would know that angle 1 has to be greater than the measure of angle 2. And similarly, if I got rid of the measure of angle 2, wouldn't the measure of angle 1 still have to be bigger than the measure of angle 3? Right, because it takes both of these to equal angle 1. So if I just got rid of one of them, I would know that angle 1 has to be bigger than the measure of angle 3, or vice versa for angle 2. How do we feel about that? Does that make sense? Taking your silence as yes, that you understand. But, okay, that was a really bad joke. Okay, now let's try the same kind of idea, but with a more complicated picture. It says, what angle measures what angles measure less than angle 7? So our focus right now is angle 7 here, and we want to figure out what angles are smaller than that. I mean, by looking at the picture, we see that angle 7 is obtuse, and we have a lot of acute angles. However, you're not really allowed to assume a lot of things in math, right? So we have to kind of rely on these relationships and things that we know for sure. So if we look at, let's say, this triangle here, right? Do you guys see this triangle, the smaller one? Well, we would know that angle 5 and angle 4 added together give me 7. So by default, then those two would measure less. But now if we focus in on this big triangle, what would our two remote interior angles be? It would be angle 1. And that would take 2 and 4 plus 1 to give me 7, so then angle 2 as well. I think that's it for sure. Okay, now we're going to shift gears here. What angles measure greater than angle 6? So what would be bigger than angle 6? So if I want to focus, what would be like an exterior angle for angle 6? So if I look at this triangle here, if we extended one of our sides, we form angle 3. So I would know angle 3 would be greater. And then if I look at the bigger triangle here, if I extend JK, we form angle 8. So I also know that angle 8 would be bigger. Okay. How do we feel? Are we doing okay? Does that kind of make sense? So now we're going to shift a bit again to something a little different. So we can actually order our angles from smallest to biggest or biggest to smallest if we know all three sides of our triangle. So it says the angles of a triangle can be put in order by comparing the side lengths. The smallest angle is always opposite the shortest side. Again, the smallest angle is always opposite the shortest side. Whereas the largest angle is always opposite the longest side. And that makes sense, right? Like, if I'm looking here at my triangle, I notice that 7's my smallest side. Doesn't it make sense that then angle A would have to be my smallest angle, right? Because it's opened up the smallest to make that side of 7. Whereas, look, B is across from our biggest side, so B has to be opened up the widest to form that side right there. So here we go. It says order the angles from least to greatest. So on these homeworks, just make sure you pay attention as to if they want smallest to biggest or biggest to smallest. So if we go here, least to greatest, so we just said our smallest side was 7. What angle is across from that or opposite? That'd be angle A. What's our medium length side? Well, our medium length side would be 10. What's across from that? Angle C. And lastly, our biggest side is 13, and that angle B is across from 13. Okay, now can we flip it? Can we go the other way? This time, we want to order our sides based on our angle measures. Again, it says the sides of a triangle can be put in order by comparing the angles. The shortest side is always opposite the smallest angle, and the longest side is always opposite the largest angle. So if we look here, it says order the sides from least to greatest. Well, we're missing an angle measure, so is this even possible? Like, I think we might be done. Like, I don't think we can do this if we don't know what F is. But you guys are right. You can find the measure of angle F by subtracting from 180. So 103 minus 42 should give us what? 35, I think. Okay. And now we have enough information to order our sides from least to greatest. So we need to find our smallest side, or excuse me, our smallest angle, which is 35. Now what side is across? That would be side EB. Our medium angle would be 42, and that is across from DF. And then our largest angle is 103, and that is across from EF. Okay, we have two examples on the bottom of your sheet. I think you should take the next few moments and label them from smallest to largest for your angles and your sides from shortest to longest, and then we can go over them together. Did you pause the video? Okay, I'm assuming you did, even though I doubt you did, but I hope you did. So we are going from smallest to largest for our angles on this one. So let's find our smallest side. Our smallest side is 30, which is across from angle T. Our medium side, 35. That's across from angle R. And then our biggest side is 38, which is across from angle S. There we go. It's that easy, folks. And then lastly, it says order the sides from shortest to longest. Again, we have to find that missing angle measure. I'm going to do that real quick. So 180 minus 82 minus 54 gives me 44. Okay, here we go. So my smallest angle out of these three is 44. What side is opposite it? That would be XY. My medium angle is 54, which is across from YZ. And then lastly, our biggest angle is Y, which is across from XZ. This was a good lesson, nice, short, and sweet. I hope you have a super great day, and we will be in touch soon. Talk to you guys later.